All right, this is the last video in our chemical names and formulas chapter where we're looking at empirical formula. And finally, we're going to see how do we get a molecular formula from our empirical formula. So we're going to start off with a practice problem on empirical formula calculation. So go ahead and pause the video and take a crack at this first practice problem, and let's see how you do. Okay, welcome back. Let's see if your answer is correct. So I have a compound that has 40% sulfur and 60% oxygen by mass. And we said in the last video, we want to assume we have 100 grams. So that means I would have 40 grams of sulfur. I'm going to put that over 1 because I'm getting ready to do some conversions. And I'm going to have 60 grams of oxygen. I'm going to put that over 1. The second step is to convert this to moles. So I have to use the molar mass. I have 32 grams of sulfur in 1 mole of sulfur. And I have 16 grams of oxygen in 1 mole of oxygen. Grams cancels. And that leaves me with 1.25 moles of sulfur and 3.75 moles of oxygen. Step 3 is to find the mole ratio. So I want to divide each side by the smallest amount, which is 1.25. And that gives me a 1:3 mole ratio, meaning that my compound, my formula is going to be, my empirical formula is going to be SO3. So some of the problems where they ask you to calculate the molecular formula, you'll have to do this first. For this next sample problem, they give us the empirical formula. And they tell us that the mass is 283.9. And the reason they can do this, the justification behind this is you can put a compound into an analytical piece of equipment and it'll spit out the compound's molecular mass. So that's a piece of information that we can get through testing. So very simply, to find the molecular formula, you have to do the following. You take the molecular mass, and we're going to divide that by the empirical mass. And the value that that gives us then becomes a multiplication factor or a multiplier. So I have the molecular mass. This says this is the molecular mass, but I need the empirical mass. So let's find the mass of diphosphorus pentaoxide. So I've got phosphorus, I've got 2 of those, oxygen I have 5, and I'm going to multiply that by the molar mass. So phosphorus is 31 if I round it, and oxygen is 16. So that's going to give me 62, that's going to give me 80, for a total of 142 grams per mole. So I'm going to take my 283.9, and I'm going to divide that by 142, and I get a value here of 2. That means to get the molecular mass, I have to multiply each of my subscripts by 2. So 2 times 2 is 4, so I'm going to have P4. 5 times 2 is 10, O10. This is my empirical formula. This is my molecular formula. So our last step is relatively easy in going from empirical formula to molecular formula, but we've got some practice problems for this to make sure you've got the concept down. And that wraps up the chapter. So we will go on in the next chapter to stoichiometry. That's all for now.